welcome to the September 2020 edition of Software Craftsmanship in Kendrick County. A couple of announcements. So next month is our 10-year anniversary as a user group. So to help us celebrate that, Uncle Bob Martin is going to be giving a talk on the future of programming. So that's been announced, so go ahead and sign up for that on Meetup. And we do have an opening for November if anyone's interested or knows of someone who would be willing to give a talk. Do want to give a quick shout out to our sponsor, the LaSalle Network. They're a recruiting firm. If you're interested, we can get you in touch with them. And yeah, that's all my announcements. So I'd like to introduce Ryan Stawarz and Bob Lasch. They're going to be giving a talk on GraphQL. Very excited to have them. I actually looked in our meetup, our last GraphQL talk was in November of 2017. So it's been a little while, so it's good to have a refresher on this topic. And our last talk was more of an introductory talk to the whole GraphQL ecosystem. So excited that we're going to sort of dig into, you know, Bob and Ryan have used it in a real live app, so that'll be cool. So with that, I'll hand it over to them.
All right. So I'm Bob.
I'm Ryan.
Depending on where Ryan is on your screen, that's Ryan. So let me share my screen here. Start the presentation. All right. So this is GraphQL in a Rails world. So just out of curiosity, how many people are actually familiar with Rails? Like anyone? Few? Okay, so some. So Rails is a popular web framework for Ruby. GraphQL is basically a query language created by Facebook. Ryan and I started a project together 2 years ago, and Ruby and Rails was an easy choice because we both use it during our day jobs. But we needed something to basically communicate with the front end, with the JavaScript framework or the JavaScript front end. So after looking around and after some different choices, we decided to go with GraphQL for that communication layer. So Ryan, do you have anything to add to that?
Yeah, I mean, one thing to add here, first of all, so if you have any questions, jump in anytime. You know, rather have a discussion than just lecture all day. So, but above me on that, I mean, I think the first thing to predicate would be say that when we were making our choice, right, we knew we wanted to use something different and we were using Vue on the front end. So we wanted something with an API in the back end already. So, you know, it's a strange choice, but we're also looking to test some technologies out on a new project. So we'll go with that.
Yeah, and it was something in which Ryan had started to look into, or at least started to use, I believe, in his day job, which made it a logical choice. It was completely new to me, so to be honest, GraphQL is still something that I only use on a side project. It's not something that has made its way to my daytime job. So yeah, so next slide. So why GraphQL, right? REST is nice, right? But there's issues with REST, right?
Yeah, so
especially if you're truly RESTful.
Yeah, if you're really going to build a RESTful front end, right? Bob, you can click through a couple of the next ones here, right? It can get noisy, right? We've all dealt with this, right? If you're building a front end and you want to return the user information, right? You're going to make a request to get the user. You're going to, if you want to get the next set of information, right? In this case, the user skills, that's another request. After that, if you want to get the jobs for this particular UI, right? That's another request, right? So it can get noisy pretty quickly. And you can solve that, right? People have solved this. Okay, well, we just modify the request, right? We build a user endpoint that returns all the information, right? So we can show that in the next slide here. So if we get the user, we can say, okay, well, let's just get it all at once and return it. The problem here, right, we've all run into this, is now we have a very static API response that is bulkier than maybe some clients need, right? So maybe, right, our web client is really thick and we expect our desktop to be able to handle this, but our mobile clients are on a 3G connection and we want them to be able to make a different request. So when dealing with REST, right, like, so the next step is, oh, well, all our API responses aren't standard, or we want to be able to reply different responses for different clients. So we've all dealt with this at some point over the past couple of years, I'm sure, if you do any web work, right? So go to the next slide here, Bob. There's some examples of this. Yeah, so we may not always need those fields, right? So there's things that have filled the gap over time, right? There's Hello JSON APIs, which to the right here show like, this is what a standard API response looks like, right? You can have some links and be able to traverse, the RESTful resource. You can add in smart query parameters and say, okay, well, here's this way of constructing the URL or query params so that I only want to be able to fetch these particular attributes. And then in Rails, right, with all sorts of different kind of serializers we can use to kind of, create different concerns and kind of shape that a little bit, right? But that's really what GraphQL was built to fix, right? This is a query language. Go on, Bob. So it really is meant for defining a dynamic or customizable query language for different clients, right? So it allows you to basically make different queries. It's strongly typed, so you have a contract between your clients and your server. This is what you're going to get back, right? It's self-documenting, which is beautiful. I know anyone who's managed REST API has dealt with documentation. It's a big pain. It always goes stale. Nobody wants to deal with it. It's baked right into the classes and maintenance of implementation. And then even above and beyond that, right, inside the graph, we can actually maintain who can see what field. So we can do access checks at real time based on who's accessing it. So those are some benefits of GraphQL. And we're going to fly through some of the high overview of what GraphQL is, because I know you guys have seen this before, or most of you. But if you have a question, feel free to jump in again.
Yeah, and the other nice thing about GraphQL, unlike anyone who's actually done a pretty plain Jane Rails project, right? You end up have death by serializers, right? Because you have you want to keep the purest form where you've got your user or your skill or what have you, but then you need to be able to search off of that. So then you need to modify the serializer based off that. You need to be able to, like Ryan said, you need to be able to return back more than just one piece of information, so you need a serializer for that. The next thing you know, your serializer directory is gargantuan, so it can get out of control. So next slide. Why Ruby on Rails? Well, actually, this is kind of take a small little side note. When we first started our side project, Match Made Hire, we didn't choose Rails. We actually chose Elixir and Phoenix. And throwing basically 3 new technologies into a project at the same time, it did not go well. So we kind of fell back to what we were very familiar with, Ruby on Rails. And it actually is really, for all of Ruby's warts and issues, speed and cumbersome at times when it comes to certain things, it actually is really, really still, even to this day, fun to get stuff done. So, GraphQL overview. So, GraphQL, there's a schema that defines what can be queried. Schema has types, and every type has basically 1 or more fields. Each type should have an ID field that makes it uniquely identifiable to the system. So in our case, we're going to, as we go through these slides, we're going to kind of show examples of what we have done for Match Made Hire. We're going to use some of the different, we're going to use some of the code, the schema, some of the Rails code, and use that as examples as we go forward, just as a small warning. So when you see stuff like skills or users or candidates or things like that, we kind of leverage the code base that we had as opposed to coming up with a contrived example. This is actually all based on experience of a real life project that Ryan and I, like I said, have been working on for the last 2+ years, so on and off. So Ryan, why don't you pick up the rest?
Yeah, so the way you model your graph, right? The nice thing about a graph API is that it allows you to kind of start over. If you have a legacy database or a legacy schema, right, you can put in a graph that creates a facade, right, around how you want it to be exposed to your clients. It doesn't need to map one-to-one to your database. It doesn't need to map one-to-one to your models, right? It could even, be a facade over legacy systems and distributed systems and whatever it might be. Each field and type can map to whatever it needs to. as it resolves, right? So yeah, and so that's a quick overview there.
Yeah, the other nice thing, like Ryan said, one of the things that's actually really cool when you first start using GraphQL is that we've all been on projects where the projects go on for a year, 2 years, 3 years, 4 years, and the schema kind of evolves, right? Where there are certain lumps, little areas of the schema where it's like, well, we've got this separate object over here, we've got this separate table over here, and they really should be the same, or they shouldn't be what they are. You can actually mask that and actually fix those issues and kind of make it the way you want it to on the front end. And that part actually with GraphQL is really, really nice. So just thought I'd throw that out. So GraphQL has some simple data types, string, int, float, Boolean, ID. These are all not rocket science. They're all, if you've done either JSON or Ruby, these are all fairly familiar to you. The date time and the date are the ISO 860, right? 01, I should say, encoded datetime formats. You can actually do JSON through it. This is something in which we have, at least on our project, avoided. If you're doing JSON in a project in your GraphQL, more often than not, the general rule is that probably should be broken out into separate objects. So, have anything to add, Ryan?
Question on that, Bob. If you're doing hierarchical data structures, like you don't need JSON for that. It's just kind of built in with GraphQL, right?
Correct. And we'll get into the queries right after this slide. So, but yeah, I mean, it is very hierarchical how it returns data, and can actually be fully customized based on what the query you send in. Well, let's get to that.
Yeah. So just a quick note on the JSON stuff, right? So there are legit data cases where, like, maybe you're being lazy, maybe you're shaping out your API and you're trying to figure out what is this really going to look like, and maybe it's just a hash of data, right? And that's a totally legit case where you're like, well, it's not really defined. It's just a hash of keys and values. Let's just send it down as that, right? Like, there may be reasons that you would create this, but for the most part, you want to create a richer type that has a schema. Otherwise, you're kind of just not really using the full power of Graph at that point.
Well, you would probably say though, Ryan, 9 out of 10 times, if you've got a propensity to return back down JSON, that's a smell, right?
Yeah.
Okay. I just want to make sure that you and I are on the same page.
Yeah, no, and I've been maintaining a GraphQL endpoint for probably 3.5, 4 years at Doximity where I work, and we've gone through a lot of growth pains on this. So I have a fair amount of experience of working with it.
Yeah. So let's run through just a real simple query via GraphQL, what it would look like, right? So one of the things I kind of warned you guys about earlier was that you're going to see certain things that kind of terminology or business logic, et cetera, things that we kind of stole from our Match Meet Hire domain. So Match Meet Hire is a website that Ryan and I have created that allows candidates to go ahead and sign up, put in their job preferences, et cetera, and then what we do is we deliver potential matches to the jobs, right? So in this particular case, this query, right, goes ahead and actually returns back just a list of skills, right? It's a very simple query. And if you notice here, the query, right, is this actually JSON? This is where there's class participation, not Ryan and I. Just want to make sure people were still there and you guys didn't put us on like some looped video. Michael, is this JSON?
It's not JSON.
It is not JSON. Why is this not JSON?
It's just not formed correctly.
It's not formed correctly, exactly. So you'll see that in some cases in GraphQL, thank you, by the way, Matthew, because I think Ryan and Michael and everyone else was going to basically sit here and let me wait for an hour until someone responded. The GraphQL query syntax has a kind of JSON smell, but it's not JSON, right? It's close enough to JSON that makes you think it's JSON, but really it's not JSON.
It's its own query language.
Yeah, but it's close, right? It has that kind of feel-ish kind of, right, JSON feel-ish. The results, though, well, I should probably talk about this. So access top-level query, right? This, when you go ahead and specify a query, it starts with the word query. I think in most cases, I'm trying to think in our code base, Ryan, do we actually have query or do we leave it off?
We usually leave it off, but there are valid reasons to need it to put it in. So for example, you hit the next one, right? You can name the operation. And so on your server, right, you can begin to log these operations and know what operations are coming back, right? So there's value add in specifying this. But it's implicit, right? If you're just making an ad hoc query, you don't have to.
Yeah.
And here, we're actually asking, in the query is a top level object, right? So it's implied. On the query type, right, we're accessing skills. And then on skills, right, we're accessing, for in this case, skills is going to return an array. We can look at that schema later. But on each skill, we're going to pull, we're asking for, give me back the ID and name for every skill type that's returned.
Wait, I can't not get this right. So this is what the data looks like from this query, right? You'll see now you notice that the results are actually JSON, right? Which actually works really well for pulling this into a browser, right? And or pulling this into JavaScript, right? So you'll see here in this particular example, we asked for skills and we want the ID and the name of the skill. And we got back, and if you were to go and take a look at the schema or the database, there's actually more data on skills. We specifically selected that we only wanted the ID and the name, and that's exactly what the server gave back to us, right? Ryan, anything to add? Okay,
Nope.
perfect. So GraphQL actually, on the Ruby side, comes with a really cool little tool here called GraphQL, which actually allows you to go ahead and run queries, right? Try queries, try mutations, try things out to see if they actually work correctly, right?
It's actually a React front end. It comes built in with the playground. I think with the gem, I think it automatically creates an endpoint for it. But you can actually mount this anywhere. This is actually deprecated. The latest version is being merged with another product called GraphQL Playground, which is that standalone client you can get as well or mount on your app. It's actually richer and a lot better. We just haven't plugged it in yet. So,
yeah.
But it's nice because the schema itself is self-documenting. So in here, you can actually click through all these types and get the definitions for what a query is, what fields are on query, and then look at each field and figure out the types from there and go on. So we're going to be talking mostly about the GraphQL Ruby gem itself. This is what most of GraphQL APIs in Ruby are written in, right? So this has a whole engine that you can leverage to build your project with. It comes with a quick generator like most Rails installs do. And if we go to the next slide, we'll see that, that's the command you execute. It generates some top level stuff. It creates scaffolding for the GraphQL schema itself, some top level query mutation types, or which are just classes, and some base object types and classes and fields. And then, yes, so it also adds a route, which is basically a simple post to API GraphQL. So everything's a post in GraphQL. It's one route, one endpoint, which is really one nice other thing on top of REST, right? REST in Rails gets to be kind of a boilerplate. You keep adding a new controller, you add a new index, a new get, right? Like a new show, a new, right? Like you can kind of avoid all that, right? The next thing it adds is also the controller as well. Yes, and so this is really simple, right? So we're not going to talk much more about this because everything underneath the hood here happens underneath this MMH schema.execute. So what this does is marshals the information off standard Rails controller, right? Takes our params of variables, takes our query, which is the string, the actual query that you're posting up, and it passes it along into the execute of the schema. So we're going to take the schema that was generated. We're going to say, hey, go execute this query, give me the results. I'm going to render it back as JSON. And that's all I really need to touch of our controller from here on out. Everything else is powered by the engine itself. For the most part, we'll get into some error handling and things like that can bubble up. But for the most part, this is what we're looking at. The power here is that the schema takes these inputs and basically goes through the system, goes through that query, parses it, and executes it according to your field definitions. So
if you're doing a Rails application and you're doing it kind of the traditional way, right? Your models are probably, I don't know, probably maybe 20% of your code base, right? Your controllers are probably another 20, if not, maybe 20%. Your front end's probably quite a bit more these days, right? Probably at least 40, 50%. And then you've got probably service level objects that are at least 10, if not 20%, right? With GraphQL, right, most of the code, especially in our project, most of our code base is on the either JavaScript side or in the GraphQL section. It's very little actually turns out to be in controllers. Although there is some models, there's not a ton of models. I mean, we have a lot of models, but there's not a lot of the same code you would find in a traditional Rust-based application. There's just not a need for it. GraphQL handles a lot of that for you. So. Okay, assume that was there. So this is what our project looks like. Your mileage may vary. There is actually, when you go ahead and run the install, it creates a GraphQL directory, right? And inside of there, you've got inputs, mutations, and types. There's basically 3 types to GraphQL. There's queries, mutations, and subscriptions. Queries allow you to retrieve data out. Mutations allow to add, update, or delete data. And subscriptions allow you to update when a particular event occurs. It's kind of a pub sub built into GraphQL. For our project and for the case of this, for this presentation, we're not really going to cover subscriptions. It's not something in which we haven't used it all on Match Made Hire. Have you guys used it at all on Docs, Ryan?
We talked about it, but we haven't had a full need for it yet, right? So basically, you can couple. I'm trying to think of action cable, right, to your front end, which would basically allow you to set up a subscription, a GraphQL subscription, right? And essentially, anytime data is updated, you can funnel that up back through that WebSocket, and the query, right, that you execute on the front end would automatically get those updates, which is actually really nice. We haven't had a need for that yet in our app. So
yeah. So in essence, though, right, the controller level, right, in Rails covers all your CRUD events, right? Your creation, retrieval, update, and deletes. With GraphQL, the controllers, the serializers, a lot of those service objects, although there are still room for service objects, a lot of that kind of goes away, right? Instead of having this huge, anyone who's been on a Rails project that's been lasted more than 2 or 3 years, right, and you've been working on it for full time, the controller directory is gigantuan, right? There's controls all over the place. With GraphQL, that kind of dissipates. There's not a need for it anymore. So declaring a GraphQL schema in Ruby. So you have to actually go ahead and define how to basically access your data. There is a file called basically a schema file. And in our case, this is generally what our file looks like. There's a little cruft that's left off here, but you basically point it where the mutations and where the queries can be found.
yeah.
Right?
So the crux of what's actually going on. So if you remember our controller, we called mmh schema.execute. All of that comes from the base class here. And it determines what fields are accessible, right? And we're basically saying on the top level, you have a query and you got a mutation. Those are the 2 things you're going to access at the top level.
So queries, go ahead.
So
I've been going first, so I'll let you go.
We have a query type here. So this is what we defined. Our query field was this query type. And then our mutation was this mutation type, right? And on each of these, we will declare fields, and that's what we'll do in the next slide here. So as an example, we're going to define on our query type, we have a field called skills. It is, you can click next, Bob, here. So it is it declares the skills field as an array of this type of skill, right? So this type is a class. We'll get to that here in a second. It also declares that the value cannot be null, right? So in the schema, when the client's asking for this information, it knows whether or not it has to handle a null or not, right? When you have iOS clients, Android clients, when you have varying devices that are accessing your graph, a lot of them have tooling for this built in, and they can actually generate their types directly off of this. And it will actually know whether or not it has to demarshal nulls and do type checks for that. So most of your client languages are strongly typed for them, except for the web ones. But it actually helps on when you're developing an iOS client or using Kotlin or something like that for your Android. So here in this type, what's going to happen is it's going to say, okay, well, I have this field. If somebody tries to access it, it's going to call skills on this type itself, right? So it's going to invoke this method, which is actually going to basically use our model, our skill model, and load them all up, or return a relation for that matter. And then from there, right? And then, and just one note here, right? We have, you get your documentation for free. So just by declaring what description, like describing what this field is, that goes in the schema. And that schema is discoverable and queryable. And any tooling around it can actually look at that and say, here's what this field really means, right? And there's documentation. So when your developers are in your code base and they're changing the definition of this field and understanding of it, right? They can update description inline. There's no other tooling around generating that documentation, which is actually really nice. It goes a long way. I find all our mobile and developers really love that.
So in this particular case, right, skills map directly to the model in our database. We have a skills type, right, type object on the GraphQL side, and then we also have a skill model on the Rails side, right? So in this particular case, they match up one-to-one, right? Does it have to match up? Not necessarily, right? But in this case, it does. So here we define our fields on the skill type, right? We have an ID, we have a name, and we have approved that in the URL, right? URL is, what was the URL for here? I don't even remember.
It was awesome. It was a great URL.
It was a great URL. I don't even remember what we had that for. So
You only had a description.
Clearly, right? It's clearly not self-documenting that well. So in this particular case, so if you take a look at the datetime, right? Rich type for declaring the datetime.
So if anyone's ever dealt with an API before, right? And you've gotten this, you have developers developing 5 different fields on your API or different, it gets updated and your times don't match, right? Like, or you're integrating with third party, right? It's a great thing when you know exactly what the format of that data is and the client goes, oh, I know how to parse that, right? This is how we handle that datetime.
And they don't have to parse it like 15 different ways, right? Because you've got 15 different developers working on it.
Or protect against this format or that format or whatever it might be.
Yeah. So this is a little slightly different query, right? Here we're actually going to pass in a search term. We want to return back all the skills that match up with Ruby, right? So what we do here is we define a search field on our schema, and we give it an argument, search term here. We define the type and say that, okay, first search term is actually required, which, to be honest, why would you search if you don't give a search term? Search actually maps to a method in the schema that basically you pass in the search term. And here we're actually returning back oops, I have a touch screen, sorry. In this particular case, we're returning back number of skills that match basically, and we order them based on the name. Brian, anything to add?
No, I don't think so. I mean, the one thing to note here is just from a client perspective, right? We're declaring this argument as required. So if you actually try to execute this without the argument, any client that use any client library will actually not even let this get on the wire, right? It won't even let you make the request because it's typed and says, nope, that's not valid, right? And it'll actually raise an error client side before you make that full round trip for the server to say, hey, that's not right. You need to give me a search term, right? All that can happen in the client before you waste any bandwidth or any time trying to figure out whether or not it's a valid query.
Yeah, there's a couple other things here in play that we probably should mention. One, Ryan's a big fan of the documentation in place. So here there's really poor documentation in our case, but you can actually have documentation. Here we can actually return back a nil. And then the other thing that isn't really covered here that we probably should at least mention is that if you wanted to have the field not match up the method name, you can actually specify what method to call here to suffice this to resolve this query. And for those of you who are familiar with Ruby, right, you'll notice that field is actually a block and argument is actually basically called within that block, right? That should look familiar to all my Rails/Ruby folks. So,
What's with that type ahead thing?
type ahead.
Or auto suggest result? There we go. The type.
Oh,
That's the type that's going to be returned from the search field,
yeah.
right? So when you declare a field, it's the name of the field, the type of the field, and then options are a variable after that. So in this case, search is going to be a result of auto suggest result, which I can't remember exact type of that right now, but you know, in theory, it could be different kinds of results in there.
Yeah. And I mean, we could have gone ahead and if say search was simply a search skills, right? Say we only had search and it was only going to be skills. This easily could have returned back an array of skills, right? But the reason why we've kind of obfuscated this a bit was because we wanted to make it a bit more generic, a generic search. So auto suggest result kind of allows us to obfuscate the results back. So that's a good question. Anyone else before we move on? No? Okay, next one. So mutations. So for as awesome as GraphQL is for doing queries, this is where the awesomeness kind of subsides a little bit.
Not on the Ruby side, mind you. Right?
Not on the Ruby side, on the GraphQL.
So this isn't a GraphQL specification in general. It's like somebody came up with this great idea in creating GraphQL and how we query, and this is, and I was like, yeah, that's great, let's do it. And they implement, and they ran, and it's like, wait, how do we change data? I'm like, oh, we should add mutations, and it's like this bolt-on to GraphQL. So it's not as pretty or as obvious as the rest of the query language, but anyway, I'll stop.
No, it definitely has a farmhouse design feel to it a bit, where they created this beautiful house for querying and for getting data out. And then someone's like, how do you change data? And they went, oh, what? Hey, we gotta change data. Oh, crap. So then they bolted this thing on, and so it does have a little bit of a discombobulated feel to it. So in our system, this is one of the mutations that we have. As you can see here, you define the arguments that you can pass in, whether or not they're required, etc. It's got a familiar feel as previous, right? You're mentioning what it is, the same thing as a field. You mention the type and whether or not it's required, right? And then there's a resolve method here that actually goes ahead and gets executed on the execution of it, right? So we do some validation on whether or not the user is found, and deliver an email if they actually were found, and then return a result. So the success result method is just a common result handler that we've used across the board. One of the things we've tried to do is keep our results back from mutations fairly consistent. So we have a common handlers for both failures and successes across the board. This is not something that's GraphQL. This is something that's Bob and Ryan. So
yeah, so the base mutation here implements these two methods, success and failure. And what happens is it basically returns a result that looks like a hash that has top level successful fields, errors, and then a result field on it as well, which is usually something you can override.
So nested types. So one of the things that you're going to see in GraphQL is you're going to have, things aren't going to be simply one level, right? It's going to be multiple levels. A user may have, like in our case, a user which may be a candidate, which may have skills that they can provide, they may have benefits they want, they may have other certain criteria. So very much so, you can go ahead and it's expected, right, that different types are going to have nested objects in. And in this address type, right, we've got formatted address, address 1, address 2 that are strings, but then we have city, state, city, state, and coordinates, which are different types, right? Different types that can be returned. Ryan, do you want to take this one?
Yeah, so in this case, this is a quick location. We're doing, and I'm doing some tricky things here. with the graph, just give some examples because it's not really necessary. But so I'm calling a field on query, on the top level query object called find location. I'm passing an argument location, which is looking for some main street, and it gets some results, right? And you can see where we start getting nesting in the graph, and we can go deeper and deeper in this graph depending on how we define it. You can hit the button, Bob. So one of the things to note here, there we go. I'm doing this thing called aliasing. So my arrow is a bit off in this case. That should be pointing to location : find location. So what it's actually saying is saying, I want to query the field find location, but I want to return it to me as location, right? So I want to rename it as I go. And there's a couple of value adds to this. One, if you have a client that expects it in a certain format, right, the client can say, well, I don't like that name. I want to use this name and map it to whatever it might be. It also allows you to query the same field multiple times so you can get it back in your result set. So if I made this find location in this query twice without aliasing it, I would actually override the value inside the JSON that's returned. But in this case, I can actually say, give me a find location for this as location 1, give me find location, some other value as location 2, right? That's one way to go about it. Not necessarily practical, but gives you an example of the power of the query language itself, right? So hit the button again, Bob. You can see on the right side, this is location, right? And if you go again, you can see the same thing. I'm doing the same thing for latitude and longitude. You're right, like I don't like full names. I'd rather get it returned to me as longitude or long, right? So on the right side, you can see how that alias is going on, right? Just another example of the benefit of the GraphQL query language that you get well beyond what you can do in REST, right? Or in your own query by yourself, right?
Yeah, I mean, in essence, if we wanted this, right, to return back the right results in a REST universe, right, you'd have to mesh the data on the client side, or you'd have to go ahead and create a new controller, right, or maybe a customized option, you would have to write some additional code, right? In this case, this is all for free. You get this for free with GraphQL. So here's the actual complex type that's defined in the Rails side. In this particular case, we've called it coordinates underscore input, right? We've given it a latitude and a longitude. Both are float and both are required, right?
So this is specifically for mutations, right? So if you're trying to if you don't have a flat list of information as an input, you can define more rich types for those mutations on the inputs as well.
Yeah, I mean, we have basically objects that we're defining on the server side, right? In our schema, and the only reason we've defined this here is so that we can actually pass this information in on mutations. I think that was pretty much the exact same thing you just said. Here's what it actually is being passed in, how we would be passed in. Notice how it's got ID, int, and string, right? It actually kind of makes it act a bit like a native type, right? You basically define the type here. Right here, right? So it's kind of nice. Now, one thing that we haven't really covered here in this yet, notice the exclamation mark. Anyone have an idea what that exclamation mark might be for?
I'm guessing required.
You would be correct. It is required. Actually,
Nice.
Not required. It's you can't be null, right? Yeah.
Can't be null. Okay.
Null.
Yeah, which in this case is an input to be required.
Yeah. So get my pointer out of here. So error handling.
So just talking through some of the things that can happen and how you can handle it in your graph from a Ruby perspective, right? So this is part of the feature of the library itself. On your schema, right? So here we have our MMH schema. It extends from the base class from the library. So in here, there's the schema itself, the engine allows you to have middleware, right? Kind of like you would in a rack context. In this particular case, I'm telling our schema to use this execution errors middleware, which basically wraps if any time inside that execute method when we're executing against our schema, an error is raised, it's going to actually use these rescue blocks first to determine the behavior that's supposed to happen, right? So if you go next right here, so in this particular case, if I have some custom error, right? If I raise some custom error when resolving a field, and we go through that graph and I'm getting all my data out of the graph, and one of the fields says, nope, I'm going to raise an error, right? Something happens. In this particular case, what I'm actually going to do is I'm actually say, well, if it's this kind of error, what I want to have happen is I just want to notify bug snag, and I want to replace nil, right? I want to replace it with a null value in that case. In this particular case, right, we can actually substitute any value here, right? If it was a number, we could just return 42, right? Because 42. If it was something else, right, we could do something else special here if we needed to. But generally speaking, it gives you the way to customize errors that may happen when resolving your fields as you're going through your graph. When the next one, just above this, actually shows you one you'll find all over the place, right? Active record, record not found, right? So in a traditional Rails REST API perspective, you'll probably have a top-level handler for this built in your application controller that basically just says 404, right? And just returns a 404. In this particular case, we're going to raise a special kind of error to the schema execution itself called the GraphQL execution error and pass it a message. And what that's going to do in Ruby is it's actually going to put an error at the top level of the response so the client can inspect it. So an example of that here will show you that if I try to load a skill, and Bob's supposed to hit next here. There we go. If I'm trying to access viewer, right, and for some reason I'm unable to find the user, right, in this case, which would never happen in our system, but I forced this error to raise. It would actually, in GraphQL, you have 3 top-level fields that can be returned in result. Data is where you get your data from. You have errors, which is top-level GraphQL execution context errors, right? And in this case, it automatically stuffs it in the errors and returns null as the viewer. And now the client can raise this error and actually deal with it how it feels, however it feels necessary. And there's ways, so those are 2 cases, right? So now if you don't want to handle errors within the engine itself, it's possible to actually let that bubble up, right? So in the case of my custom error, we didn't handle it here, right? We can go back to our controller, which is the next slide. And so the next slide after this, we have a custom controller, or we're going to do the custom Rails, right? Standard Rails, rescue from this thing, and handle it with a custom error, which in this case isn't really that special. Some things I've done in the past with this, though, at this point, inside our graph at Doximity, there's points in the graph that if you try to access, or you try to access a field and you don't have the authorization, right, to access that field, we actually raise a special error. There's 2 different kind of errors we can raise. In one of the cases, we raise an authentication error, bubbles up to the controller. The controller actually responds with a custom error and sets the response code to a 401, which triggers a re-authentication to our mobile clients, right? So our mobile clients then say, oh, well, you don't have authentication. So it forces them either to re-authenticate their token or even log in if they were viewing anonymously, whatever it might be. So that's an example of how we do some error handling inside Ruby.
Yeah, in our case though, I mean, in the match made hire case, there's no mobile app. I mean, we're basically we're the consumer, right? And we're also the producer, right? We've got control of both the client and the server. So the error handling is not as, say, robust as, say, if you had a mobile client or maybe a desktop app or even external clients, right? If you had external sources that were going to be consuming your graph, right? That would be much different.
Yep. Yeah, we haven't hit a lot of those needs just yet. So thing to note here, as I was saying before,
You want to go back?
there, yeah, the data, the JSON you return here, if you're raising it to the top level inside of the MMH schema execute method, the engine will make sure that the response is a valid GraphQL response, right? If you're returning your own custom error, you have to kind of massage that JSON to match this format yourself, which really isn't tricky, but it's just something to note. Otherwise, your client will just kind of throw a fit and be like, this isn't right. Okay, so something to bring up. This is a more advanced part of GraphQL, right? So, it's kind of easy in a REST controller, right? When you have a REST API, you have one response you're returning, right? In a graph, you don't know what. I'll take a step back. You can control what requests are coming at you, by locking down your schema and saying only these are valid queries. That's not always practical. Kind of defeats some purpose of the value. But in this particular case, right, we have two different queries that can be executed against our query or against our schema. We're going to get the viewer. We're going to get their first name, last name. We're going to get the candidate object of that viewer, right? So that could be null. On that, we want the ID. On the left side, we want the skills, right? We want to get the skills from the user and the ID, which is really, the skills is a skill mapping from user to the skill. And we want the actual skill values of that, right? The skill type underneath that. On the right side, it's the same thing for benefits, right? What benefits did they look for? Are they looking for? And what are those names and IDs, right? These are two different queries, right? In a Rails way, right? You hit the next slide, right? This is pretty obvious, right? Well, in a RESTful way, you do some eager loading, right? We can include the candidate. That's simple enough. But what do we do about benefits and skills, right? On the one side, if we include benefits and the associated benefit, we get, we solve one n+1 query. But what about the skills, right? So if we include skills and we left out benefits, well, what if we include both? Well, that's certainly will solve the problem, but the issue is now we're overloading, right? We're over querying for data, because if the client doesn't ask for benefits, now I've loaded them and I didn't need to, right? So this is a common problem that can happen inside graphs because of the way that the structures or the data is queried, right? And I'll give you one example. It's probably going to be hard to explain, but I'll do my best here. So you go to the next slide. We can do what's called batch loading, and we get outside the context of Rails active record, and we introduce something else altogether. In this case, there's a library called batch loader. There's several of these out there. People use these for different reasons. It's not just for GraphQL. If you have n+1s in a dynamic context, even outside of a graph, right, this can solve various loading problems for you. A couple of key points here is that if you hit this button, it's lazy, and it will load the data when it's needed, meaning that it's going to return lazy data, a lazy object, and until you access something on that object, it won't go fetch data. In a graph, in the Graph API, that's really powerful because you descend through the graph gathering objects, but you don't actually resolve the data until you're trying to render out the JSON. So you can return lazy objects throughout that graph and not actually access the data yet. We'll see an example of that in the next slide here. So in this case, right, we have a typical, here's our candidate type. We got skills. We're gonna return the, in this case, object is our user, right? It was handed down from the parent, and we go to get from viewer, right? It hands down the viewer to the candidate field and says, okay, well, the object, let's get the candidate skills off that. For benefits, we're gonna get the candidate benefits off that. And what you'll see here in the next slide is that, one more, there you go. So now we go to skill, right? And benefits exactly like this. I didn't show it, but what I added here is the batch loader. So if you click button, Bob, we have the batch loader, which is provided to us by this gem that I've added in. The next button here, next slide will show that we have this for method, which is saying the skill ID is the value off of the candidate skill object. It's the list of objects we loaded, right? I'm going to use that directly rather than making a query to skill. I'm going to use that skill ID and say, hey, batch loader, for this skill ID, return me a lazy object, right? So hit the button. What it's going to do is give me a lazy object back. And for this block, it's going to say later on, right? When I go to access that lazy object, execute this block, right? And what that block is going to do, go to the next one, Bob. It's going to actually execute the skill where clause for all the points in my graph where I've asked for a different skill ID. So as I've gone through and I've said, give me this skill ID 42, skill ID 55, skill ID 99, right? It's gathering up all those IDs and keeping in a list in memory. And then when I go to say, okay, skill, what's your name? It's going to say, oh, well, I don't know yet. Let me go fetch myself, right? It's going to execute this query for all the IDs that we've gathered in memory. And in this each block, the next stop here. So what you see here is it's telling the loader, it's saying, hey, loader, I've loaded all these objects. So anything that used to have this ID, you can now resolve to this new object I've loaded, right? So your lazy object can now use this object in memory to delegate to and get the actual values off of, all right? And so I'll show you what happens in the next slide through an execution of how this resolves through the graph, right? So if you look through the queries that are going to be happening, and I wrote this in Ruby and not the SQL, but when you go get the viewer, we're going to say, okay, well, find me the user with this ID, which we pull out of the session, and we say, okay, this is the current user. We'll just load their user. Okay, well, when we go to access the candidate, it says, okay, the candidate field says, well, the candidate is the user's candidate object, right? You're going to hit next, Bob. And then after that, when we go through the graph and we say, okay, load me the benefits, we go next. We use benefits and skills. Okay, and here we are at the batch, right? So now when we go to access each of the skills in this object, right? What's going to happen is it's going to trigger the batch loader. It's going to return a bunch of lazy objects, right? And then when we go to build that JSON at that point, it's going to actually execute this, the where for each of those in batch, right? So this is hard to kind of explain, but the value here in a graph, right? This is a simple example, but in a graph, so I'll give you an example. At Doximity, we are a professional network for doctors. And so when you load a doctor's profile, right, there's many points in that graph that we can access their either people that they went to med school with, colleagues that they've colleagued, people they've met, right? There's all these different user objects floating around, right? And we don't load them individually. We actually just batch them, say, well, get me this guy later, get me this user later, get me this user later. And later when we build it all up, all that is efficiently loaded and happens all at once. And all it happens in the background. So this is another approach of data loading. You can use this outside of GraphQL. There's various use cases for this, but in GraphQL world, it comes in very handy. Otherwise, you're either over querying your data, which you're never going to want to do, or you're going to end up with a bunch of N+1s, which are really wholly not fun. So I'll stop there. Anyone got questions on that? Because that was a lot to chew on. One thing I'll throw in real quick is the library here, I would go look at, because it's actually really simple to implement. Like, it's actually 40 lines of code, right? But it's actually really neat how it actually happens under the hood. So, but questions, anybody?
Can you go back like 2 slides? One more. Oh, sorry. Those steps. Okay, so right. So here the late binding is that each block on line 10.
Yes.
Basically.
So when we call .batch, right, we're saying for this skill ID, we're basically saying do all this other stuff later. Just give me a lazy object to evaluate with, and kind of as a placeholder, if you will.
And I'm assuming in this library, this works across siblings, right? So if you got common children, I'm assuming the batch loader library efficiently batches across siblings. Does that make sense?
Yeah, so if you have fields, so let's say we have on our viewer, for example, let's say the viewer had friends and it had recruiters, and right, those two different fields were both user objects and there were lists of objects, right? Those two siblings would resolve all at one time, right?
Gotcha.
The trick can be is it begins nesting, right? So if you're 3 nests down, it has to touch that object in order to figure out what your friends' friends are, right? And so it gets a little trickier there. Yeah.
Okay.
All right. So when to choose GraphQL, right? So when do you actually want to use GraphQL in your project? So if you need an API, right, that can be customizable per client. If you're going to do mobile, you've got a desktop app maybe you've got different mobile apps that you want to do, right? Netflix supports, do they really support 800 devices?
Yeah, it was a couple of years ago that was true, but yes.
I'm gonna say BS on that. But
think about it: Sony, Samsung, right? All your Amazons, right? Like all variations, all flavors, right? Absolutely, they have tons and tons of clients.
All right, I'll give you that. So different network speeds, right? You're going to have some on the mobile phone, right? That you're going to be potentially on a limited bandwidth, right? Is going to be much different than, say, my Xbox that is, connected gigabit to my house, right? Maintain a contract between your client and your server. This is something that, this is something that actually is of benefit. I don't know is this really a great use of, or a great reason not to use something else? I don't know.
Well, I mean, there's other ways to maintain your contract between your clients, right? Between your server and your client. This it's built in, right? There's no question, right? You have a schema, it's defined. Here's your types. When you change that, right? And I'll give you some examples. When we change our schema at Docs, our build actually validates that we didn't break our mobile clients. That our mobile clients can still function. I mean, how many times have you? I'm guessing somewhere here, right? People have actually supported mobile clients with REST. Some developer comes along and says, I don't like that field anymore, removes it, and now your client's throwing exceptions, right, on the front end for some reason because the field isn't returning what it used to field, or somebody modified it, right? That's to me, like, I use Ruby as a dynamic language because it allows me to execute really quickly. But having a contract between all these clients and this facade and my backend, right, allows me to basically say, okay, well, my backend can be dynamic, right? I don't really need the types underneath, but between me and iOS and Android and Vue, right, we all agree this is what the result should look like, right? And it adds a lot of value there.
Well, and to be honest, it's not, I don't even know if it's the contract as much as it is the client can go ahead and decide how they get the data back, right? And control what data they want to get back. So the propensity for them to go ahead and remove that field from the server side is much, much less, right? So in my case, I mean, from what I would have seen, right, or what I would have expected, that's one of the benefits, right? You eliminate a lot of controller boilerplate. I mean, you go through your controllers, how many times have you seen def index, def destroy, def update? I mean, all of that controller boilerplate goes away. It's basically just a single endpoint, right? And you've got a unified distributed services behind a single API facade. This is not something in which we have done at for Match Meet Hire, but it is something in which you guys have done at Docs, right, Ryan?
Yeah, we have some. We're not microservice, but we have definitive services between businesses, and we're all behind the same Graph API, one endpoint. That it isolates our mobile clients to have to know about a single endpoint. We can SSL pin easier, right? There's various security constraints that we can enforce that way, and then our graph layer, right, can actually, fan out to various endpoints as it needs, depending on what you're accessing.
So when not to choose GraphQL, right? So when would you not want to use GraphQL? Don't need an API, right? I mean, if there's no API, if you're doing basically just standard Rails, plain Jane Rails app, right? There's no need for it, right? You only need a web interface. There's no need for GraphQL at that point. I would probably say in most cases today, right, most of your Rails apps are probably pretty JavaScript heavy, right? For those who use Rails in your day jobs, how many of you are doing pretty plain Jane Rails apps with no JavaScript front end and you're sending basically web HTML back?
Not me.
Not you, Ryan?
No, we got a pretty heavy front end.
You have a pretty front. Is it mostly JavaScript or is it?
Yeah. We got a React front end.
Okay. I mean, most everyone, whether it's Vue.js or React or Angular, or if you're one of those poor souls who's still doing jQuery, it's still a lot of JavaScript on the front end, right? And it's a lot of reactivity, a lot of custom UI. So, but there are instances where you don't need an API, right? And you don't need that. So little plug here. So the project that Ryan and I have been working on is called Match Meet Hire. If you go to matchmeethire.com, you'll actually see our website. It just makes finding your next opportunity much easier. It's been I guess we call it a labor of love, Ryan, right? We're going to go with that, labor of love? It's been a labor of love for a while. So it's something that we've launched probably a couple months ago and are, just in the process of continued development, kind of promoting it. So if you have time, go take a look.
Yeah, we'd love feedback.
Yeah, we love feedback. Let us know what you think. And then here are some resources that we use to actually put together the presentation. Clearly GraphQL, the Ruby gem, right? The GraphQL itself, but then also the app we've been working on. We actually pulled a lot of not a lot, but quite a bit of source from our project, at least as a starting point for this presentation. So questions, comments, concerns?
The one thing that I start thinking about, because I don't have any experience with GraphQL in production at all, I start thinking immediately about how this ripples down authorization, right? How does it affect the app holistically, as far as how do you deal with authorization inside the graph objects themselves? Does it simply just translate to, you know, the key paths to the objects, and you basically specify who can access what? I'm kind of curious about that. I'm wondering if you guys have any insight into just.
Well, yeah, actually, well, in our world, right, in the match meet hire world, we have recruiters and we have candidates, right? And the goal is to kind of match them up, right? Match jobs up that recruiters put in and that candidates fit, and to get them to connect only when it makes sense to connect, right? Mm-hmm. So in our case, there are times where, for instance, a recruiter can see a candidate, but can only see an anonymized name of the candidate. I think we use like the typical, what you see in G Suite, where they do like purple squirrel or red fox or stuff like that, right? So we have a color and then a random animal that we go ahead and send as the candidate name. So there's masking and
masking. Okay.
Yeah. So there's go ahead, Ryan.
Yeah. So that's one way, right? So there's tendency, which is saying, okay, this user owns this object, and you can do that at the field level or inside the mutation level. The library itself, GraphQL library inside Ruby, actually, I think the Pro version, which you have to buy support for, gives you direct access into pundit, right? So every field you can declare a pundit role and a pundit policy for, which we use a lot at Docs. So basically, in my world, right, we have users, we have verified users, and then we've got other people inside of our application. And some of our users aren't allowed to see other people's profiles, right? So when you go to view a profile and you pull back a profile, right, on the profile field, we have a policy check that says, you know, can you view this, right? And that pundit check is actually encapsulated in a policy, right, that's used across our application, and you can encode it there, right, at the field level. But be honest, I've looked at the code for the Pro version. It's not hard to implement, right?
Yeah.
We bought Pro because we're having enough users that support is good, but it's really kind of simple to add yourself for any kind of object to basically say, okay, well, for this field, you know, check this policy. If they don't have access, return null, or return a null object patterns if the field isn't nullable, right?
Gotcha.
For the multi-tenancy, is it easy to specify that, oh, you need to start with this scope so that only certain companies or whatever can see it?
Yeah, so we have OAuth scopes that we check as well. So like if you got an OAuth token from and you're not an internal application, right, and you don't have the right scope, we'll just deny access to certain parts of the graph, right? Or if you have read access, you can see it, but you can't call the mutations, right? You can't mutate any data. And so there's some checks that we do on a permissions basis, on a role. Like on our system, we roll granular permissions that gets rolled up in roles. So as you log in, you're granted some permissions. There's some that also get checked based at the scope level that says, well, you received your authentication via some other mechanism, and you don't have the scope. So we'll actually send back a 401 and tell you, hey, you need these different scopes, right? So go re-authenticate and get scopes. And
yeah, I caught some of that passed in as the context at the very beginning there when you were showing that. So I saw the current user being passed in. So I was like, I'm assuming there's some scoping going on there for visibility.
Yeah, and in the Ruby library, the context gets passed and is accessible at every field in the system, right? So it gets passed down. So that top level of context. So we put at Docs, we put in Match Meet Hire, it's kind of it's really kind of simple at this point, right? We don't have a lot of context to need a lot of those.
Yeah.
In Docs, like there's a lot of cases where we pass in, you know, certain client information or other things we might get off of the web request that we encode and put into the context so that later on in the fields we'll have information, right? User, auth context, things like that.
Yeah, that makes sense.
So you touched on that it allows you to evolve your schema because it sort of acts as a facade over it. But have you run into the case where like you just want to deprecate a field and that's the right decision to make? How do you handle that version and that deprecation?
So GraphQL allows you to deprecate a field. There is a deprecation reason you can apply on a field in the schema. And what that basically does is ripple through the schema. And so what will happen, and this happens occasionally, is we'll deprecate a field and iOS will go like they'll start freaking out because in their build tools, things go red and they're like, well, what's the alternative? And we're like, oh, we haven't built the alternative yet. And they're like, we can't deprecate it. So we have to undeprecate it and create, right? Like, so all the tooling's there, right? You can say this field is deprecated. And so when a client accesses it, they know, oh, I shouldn't be accessing this. I should be getting the data somewhere else. And we have examples of that. For example, we have a city name on an object where we have a city type, right? So really, we want to funnel people through the rich object, the rich type, rather than the city name type itself. So we deprecated the city name, and are telling people, hey, use the city, right? And that just goes through our clients, and when they get through, and finally we have tooling around it. There's Apollo is the main client library for this, and they have some tooling for it that you can actually sign up for. And if you plug your graph into it, they'll actually keep track of all the queries that are being made and what fields are being accessed. And so you can see who's making the queries and who's accessing it. And you can say, okay, well, we need to go talk to Android because they're still accessing this field. We can't get rid of it, or the Vue client, or Bob keeps querying this for some reason, right? We gotta stop him. So
yeah, that's Any other questions? I will say Ryan came into Match Meet Hire with, you guys had already started using and been using GraphQL for a while, right?
Yeah, which is one of the reasons I pushed to use Elixir, because I was like, oh, well, I want to learn Elixir. Let's use GraphQL too. And man, on a side project, we just didn't have the bandwidth to take on all that learning at once. So.
Yeah, but as the guy who was kind of like the newbie, right? The one who was drinking from the fire hose. I will say that once you start to get the hang of it, it's actually not terrible. It actually,
an endorsement.
Well, it is what it is. So it's actually not, once you start to get used to it, it's a little bit of a different mindset, especially if you're coming from a Rails REST point of view, right? It's a bit of a mind bend, but once you understand and start to feel it, get used to it, it actually is really powerful as far as what you can return, what you can do. At some point in time with Match Meet Hire, potentially, I can see there being a mobile app for this, right? And when that happens, GraphQL is going to be something that is going to pay dividends. I will say that there was a conversation not too long ago where Ryan and I were both looking at each other and both talking, and we're like, should we have really used GraphQL? And we're like, it's a little late now, buddy. So
I think the conversation was, we could have been done in like a tenth of the time had we just done standard REST or standard Rails and cut out Vue, right? The idea of adding a thick client to it is really just added that complexity, which we enjoyed doing. So it wasn't terrible. No, it's actually been and to be honest, it was good from my standpoint because I did learn quite a bit about GraphQL.
So speaking of Match Meet Hire, if you could go back in time and start Match Meet Hire over again, would you only use GraphQL for the reads and REST for the writes? Assuming you use GraphQL at all, right?
No. If I was going to use GraphQL, I'd use it full in. Like the mutations do simplify your graph as well, right? It's better. It's not better than the CRUD that you get out of REST. It's just as good, is the way I would say it. You get typed schema and you get your results back. I would say so. If you're going to go graph, if you're going to use a GraphQL, you might as well use the mutations too.
The only thing that it buys you, Ryan, is that on the return set, right? So when you do a mutation, right, the actual doing the mutation, the actual doing the change is slightly easier in REST, right? Slightly. But the power behind doing GraphQL mutations is the fact that you can return back, right, let's say I go ahead and I want to remove a skill from a user. Say I haven't done that in a long time and I don't want to do it anymore. I hate it. I just don't want to, and I want to remove it, right? I can go ahead and when I do the mutation, I can specify the actual result set that I want to get back. And that's really where the power of the mutations come in. So, which I don't think we really, we probably didn't do a fair justice on the return set of the mutations, but.
Yeah, so I mean, for that example, right, you could, when you expose the fields on your mutation, right, as your result fields, you can specify you can return the entire set of skills at once. So the client then can make a query to get the full response back if they want to, right? So that they can update their view, immediately, right? So you can do an optimistic change on your client, say just remove it out of the memory, and then refresh it with what comes back from that mutation result. And if it didn't fail, right, then it'll get back, it'll return in that list already. So
now I will say that there are times where, depending on what you're doing, where maybe you just need to go ahead and make a call with no data being pushed in, and you just need to get like a token back, and that's it. In those particular cases, right, there are times, I think, and even in Match Speed Hire, where we're like, you know what, this doesn't, I mean, we could do GraphQL for this, but this like overkill. Like, this is too much, right? We're basically going shooting a squirrel with bazookas, and it's just not pretty. So you got to really look at what you're doing. But I'd say if you're doing GraphQL, do GraphQL. Don't, either you don't do GraphQL or you do GraphQL. Partial do GraphQL, just like grape. So it's for the old people.
Yeah, I was wondering if you're doing a mutation on, let's say, update. You're updating an object, and the result set on that update, would that normally be the object being updated, or would you have it be something else?
So generally, the way I like to structure my mutations is a couple ways, right? Because again, it's the client asking for what they want in the response, right? So you can expose the entire world on the response. They don't have to ask for it, right? So I generally expose the object that was mutated, and the user or viewer or some context or parent level higher than that, right? So that if the user, if they want to query, if let's say the object that they're in question is also a part of a collection, they can re-query that whole collection if they wanted to, right? To get an update of that whole collection so that they can, update their Vuex store, their Redux store, their Apollo store at that point.
Yeah, are you answering though? Is that is that done through the type returned by the mutation?
Yeah. So when you declare a mutation, you declare the response type, or the response fields on that mutation, the result fields. So the mutation has a response set of fields they can query for as a result, right? So you can add 100 fields on a mutation. You post up an ID, and you can ask for 100 fields back, right? Whatever that might be. There's no real limit. It's whatever structure, whatever fields you put on that type, that mutation type.
Okay, and if you have a validation error on an update, what would typically be expected in the return? Like if I ask for a copy of the object back that I'm doing the update for, and I have a validation error on the update, so my update doesn't get saved. What is there an expectation on what should be returned in that case?
So this is where on our mutations, you saw we had that base mutation. That's exactly for that reason. On all our mutations, there's 3 fields that always get returned. There's a successful flag, which has returned you to true or false. So you can immediately query whether or not it was true or false. Don't have to mess with anything else. There is an errors object, right? Which is an array of error objects. So there's an errors field, which is an array of errors object, which coincidentally looks a lot like an active record errors model, right? Like, for various reasons, right? So we can just map that right in, and you return the set of errors, and it looks almost identical. And then there's a result field, which is the key thing that's being changed. And then you can add in other fields on that mutation specific. I think we added user or viewer to that as a top level field as well. So
Yeah.
you can kind of construct what your response looks like in the way you set it up. But that's generally in my experience what has been necessary as a result.
Okay.
In most cases, Michael, and at least Mansion Meet Hire, most cases we return back basically the viewer, which is the user, right? Because for us, that's our base level object that everything kind of anchors off of. So it just makes sense to return back the viewer and then let them decide what from the viewer they actually want to go ahead and pull back.
Okay, but that's in addition to a success field and an errors field that.
Yeah, but again, those aren't like GraphQL like specific things. That's just
Right.
things that we have decided that we want to put in, right? Kind of standardize our response across the board and just kind of be more consistent, right?
In the response, these are all under the data, not under the errors at the top level, right?
Correct. So the errors at the top level of the graph are really meant for the engine, right? These are things that happen during execution engine that are unexpected, right? In a case of a mutation, errors are valid, right? You posted up an email that's wrong, right? We don't want that at the top level. We want that in the context of that mutation, and that's in the result or the response of that mutation.
Excellent. So, I mean, I may have mentioned, not in this meeting, but I mentioned my company's currently starting with going down GraphQL with a Rails backend. And I'm going to just say that a lot of people out there are probably doing things in a way that's going to make their lives harder and was making my life a little harder. And it sounds like you've got a better idea.
So Michael, what was your driving force behind picking GraphQL, other than the fact that it's cool?
The standardized schema and there being a contract that we didn't have to I didn't want to sit around and decide all the things like, oh, well, we're going to have errors over here and data over there. I just wanted that decided for me. And there's also potential customers could use this in the future. So right now it's just between the web front end and the back end, but there's desire to open things up for customers to be able to do queries somewhere. Maybe not the same queries at the beginning, but eventually they might be the same queries.
Yeah, I mean, if there was no desire for ever, like your boss was going to tell you, look, we're never going to have people access this data, and it's just never going to happen. Then I would probably go, okay, well, is GraphQL the right thing? It's probably about a 50-50. But if there's any smell that you're going to be sharing this data with external sources, then yeah, I mean, GraphQL is a great solution for that, right?
Yeah, we actually had a meeting about that, because some of the managers were like, yeah, we went down this path over on this JavaScript app, and we have these reservations, and just wanted you to know about that. And they were very fair, and they were basically the same as what you're saying, like could come out 50-50. And I mean, ultimately, since you mentioned you have this response object for the mutations that kind of it's not like one standard GraphQL response object that everyone's expecting, because as I was Googling the internet, most people are like literally returning the object mutated and not like a generic response type object. And everything is geared around that. And like the errors were being basically jerry-rigged into the GraphQL errors. And so there's tooling to do that, and I'm like, oh, okay, well that's interesting. This kind of feels a little off, but I do kind of like your idea of having one big root object so that they can literally query whatever they want.
Yeah, we have a standard. So we implemented an interface that has these three things on it: successful, errors, and result. Right, and you can override the result field to be any kind of type at that point. And so I learned early on when I first started doing this, I went down that first path, like, okay, well, I'm going to return this thing I just mutated. I'm like, wait, how do I know it's not right? Right? And it just didn't feel right. Exact same thing. So I was kind of surprised by that too. And again, this is where mutations are kind of a afterthought in that regard. But to an early point, Bob's question, like my perspective is if you're going to write an API, you might as well make it graph because the overhead in doing so isn't there's just no much, there's the only overhead is in learning it. And once you've learned it, right, the value add is beyond that. So if you have APIs and you're going to continue to maintain and build an API, the graph just adds so much more to that than you're ever going to be able to build with your REST APIs.
Well,
but
that's what we found. We did a spike. We did a spike to kind of flesh that out, and that is what we found as a result of the spike was going GraphQL did make it easier on the back end. Just get things running. All that boilerplate, like with REST, you still need to write a bunch of boilerplate and stuff, and that's just. It was actually faster to learn GraphQL than to write the boilerplate because I've done that at another job.
Mm-hmm.
I will say, Michael, that if you have, I mean, the moment you have to share the data with someone else, at that point, it's pretty much game over. You really should strongly consider GraphQL. But if you're, I mean, and if you've got a system like the size of Docs, right, then I would probably say GraphQL. I can't imagine doing all that without GraphQL.
Well, absolutely. We do have to share data at some point. That's just not, like, we just haven't gotten to those stories yet because we have other stories in front.
Okay.
So right now, the stories we're working on are just working with the React front end. But like, 4 months down the line, we've got stories coming up that are like, share this with customers. And it's like, well, we'll have the GraphQL infrastructure there. We'll just add endpoints and it'll be done. So, and it's looking like it's going to be a lot easier having gone GraphQL for that.
Yeah. And to be honest, it helps if you have someone who's been doing it for a while, speaking, from experience, right? But, if you got to start from scratch, it's not terrible.
No, it wasn't terrible.
It
Certainly
helps if
not.
you have Orion, though. I'll be honest, it helps if you have.
Oh, absolutely. I'm sure it does.
I'll be more than happy to answer your questions. I'll give you all the pain points I've been through. It's been fun.
It's been fun. Any other questions?
All right. Well, thank you very much, you two. I think this is great. And thanks for everyone for attending. Yeah. Sign up for next month. Celebrate our 10-year anniversary with us.